Hi everyone. Today we are going to try to solving this problem together. So this is the second problem set 02. This problem set have two problems. The first one in number 0 and the last one in number 1 here. In this video we're gonna try to solve the first problem together. In this problem you will have a positive integer number n, for example 1 2 3 4 5, and you need to find number n1 which is the biggest prime number but smaller than n. For example, if I give you the number 6, so the output must be number 5 because smaller than number 6 we have a number 5, and the number 5 also the biggest prime number which is smaller than n. Because we still have one more prime number smaller than 6, but it's in number 3, and this is not the biggest number. Or for example, if I give you number 7, the output must be number 5. So we can look at our implementation here. So how we can solve it? The first idea is we need to know how to determine positive integer number is a prime number or not. So we already solved this problem in the last video. So if you have forgot, you can recall what you need to do by rewatching the video. And in this video, let's discuss about the idea how to find n1. So n1, for example, if I give you the number 7 here, we can see that we have number 2, 3, 4, 5, and 6 number. Or you can also have a number 1 here. We can see that the biggest number must be the number 5 because 6 is not a prime number. So you can think the idea that if you use a for loop, go through from number 1 to number 6, you can list all the prime numbers in the interval of number 1 and 7. Okay, but it's not a good way because if you can think about the opposite direction, if we go row number 6 to the number 1, so the first prime number you hit here, number 5, must be the biggest one. Okay, because we want to find the biggest one, we need to move from number 6 to number 1, from the bigger to smaller numbers. Alright, so number 6, it means we get start at n minus 1, and we're gonna stop at 1. But keep in mind, stop at 1 actually means we stop at number 2 because number 2 is the smallest prime number. Number 2 is the smallest prime number. So we don't need to scan the number 1 here. Okay, so that's it. That's it. The idea is so easy. I hope you can capture the idea to solve this problem. Okay, so how can we go in the descending order in a for loop? So you keep in mind that in the for loop we have a parameter called step. So if you transmit a negative number, so it means we are going for loop in the reverse order. Okay, for reverse order. Okay, so that's it. For example, here I provide some implementation for you. So we have 2k here. 2k's. First one we can find, so I mean n1 exists and the second case is n1 does not exist. So what happens when n1 does exist? You can think a circumstance that is the number 2. Number 2 is the smallest number, so you cannot find any prime number that's smaller than number 2. So if n is smaller or equal to number 2, so n1 does not exist. In this case, we want to inform the users that we cannot find any n1 number satisfies the condition. Okay, so to do that, we need to apply a technique called Sentinel value here. So in this technique, we have a flat value variable equal to false. We want to assume that n1 does not exist, and we're gonna go through from n minus 1 to number 2. Keep in mind number 2 by using the negative step minus 1, and then this is the code for determine this n1 number is a prime number or not. It's just similar to what we have discussed before. in the reverse video. Okay, so when we finish the for loop here, we can consider the number of divisors. So if the number divisor is 0, what we need to do, we're gonna set the flat equal to true. It means the first assumption is false. So n1 is it. n1 is it. Alright, so we train the value of flat. So that's the reason why this technique called Sentinel value. And then we gonna break. It means we want to exist the for loop. We don't need it anymore because keep in mind that if you could still go through the for loop, even though you hit the first prime number, you will hit the second prime number in number 3. But number 3 is not what we want to find. We're gonna consider the flat value here. So if value is true, it means we hit this k. So it means n1 is it. Okay, so we're gonna read now n1. Otherwise, we read now not found. So that we need to do. I'm gonna explain a little bit about this for loop. So in the reverse video, we consider the count of divisor e equal to true. So it will be the random number. But in here, we consider 0. Why? Because in the last video, we moved from 1 to n1 in here. But consider here, if a number is a prime number, it means it doesn't have any divisors in the interval from 0 to n-1 because it only have 2 divisors. The first one is number 1 and the second one is itself. Alright, so we can say that in the interval between 2 and n-1, the prime number doesn't have any divisor value. Okay, so that means in here I consider this scenario just from 2 to n-1. And if the number of divisor equal to 0, it means this number in here is a random number. So that's the only idea. So let's execute the program and see what happened. So if I give the number 7, alright, provide number 5, so that correct. So let's try with another test case, number 2, so not found. So it's exactly what we need to do. Okay, so this is enough for this video. Hope to see you in the next video. Bye.